Hello everyone, this is Mar Haddad here again. Now we are going to do lab number 10 of this course, and it's going to be about the passive interface in OSPF. Before we start doing the lab and we go through all those points that you can see here in front of you, I would like first to explain what is the passive interface in OSPF and where to use it, and then we will go back to this lab and we go point by point like we always do in order to see how we can configure the passive interface in OSPF and do some troubleshooting. Okay, so let's first see what is the graph we have and give some explanation about the passive interface in OSPF. Here, as you can see, we have this graph here. We have two routers connected to each other on the network 192.168.12.0 as always, and both of them are inside area 0, the backbone area of OSPF. Imagine that we have configured the OSPF on router 1 and we have configured the OSPF on router 2. Router 2 will advertise the connected network, which is only this network. And router 1 will also advertise the connected network, which is this network here and also this network. Okay. Now remember, when we enable OSPF, then the router will start sending the hello packet to the interfaces that we have already put in OSPF. In this case, router 2 will always send hello packet from this interface. Router 1 will send hello packet from here and will send also hello packet from here. Now, we need to have the hello packet to be sent from Ethernet 1 of router 1 and Ethernet 1 of router 2 to be able to form the neighborship. That's something we've seen it during this course and the topic of the hello packet. So we have seen that we need to have the hello packet working in order to form neighborship between the two routers. But the question now is, do we really need that router 1 send the hello packets from Ethernet 2? Actually, I don't think so, because after Ethernet 2 here we have a switch. So this is a switch, and the switch is connected to those PCs. If we leave Ethernet 2 like it is right now, so anyone who is sitting here on his computer, he can put some type of capturing or some type of emulator of OSPF, and then he can fool the router 1 saying that he is also a router here. So there are many tools you can use. Then he will say that I'm a router and with an OSPF enabled. Then in this case, this PC here will form neighborship with router 1, and then he becomes inside the area, and then he can get all the routes, or he can also inject routes himself. And that's something we really need to avoid, to not allow people who are inside our network to do that. So what is the solution here? So the solution is, in this case, will be that we don't change anything on this link. We need the hello packets to go and come from router 1 to router 2 and vice versa. But what we can do, this interface here, Ethernet 2, we can make it as passive interface. What does it mean, passive interface in OSPF? Passive interface means that this interface will not send out hello packets anymore. Okay, in this case, you can see that Ethernet 2 doesn't really need to send hello packets because there is no any other router to form neighborship with. Then router 1 knows, when you just put passive interface on Ethernet 2, that he doesn't need to send hello packet anymore out from this interface. And in this case, we can secure our network to not form neighborship with some rogue routers or emulator or whatever. Then people can use it to be able to join our network. Okay. Now, there is a lot of confusion in passive interface. People think that, okay, when I do passive interface, then in this case, the whole network, like this network here, which is on Ethernet 2, will not anymore be advertised in OSPF. That's not true. When you put a passive interface on an interface, the network connected to it, which is 192.168.1.0, will always be seen from router 2 here, because you have OSPF, we said, enabled here, and OSPF here, and we've said that those two networks have been advertised, this and this have been advertised by router 1. Okay, even though that we put Ethernet 2 as passive interface, those two networks will still be seen from router 2. Okay, actually router 2 will see only this network from OSPF because this network is connected to it directly. Okay, so when you put passive interface, the only thing would happen is that Ethernet 2 will stop sending hello packets out of it. Okay, so now we know what is the passive interface on your OSPF. Let's now go and start doing the lab, and then you will understand it better when we do it on the lab. Okay, now here we are in the lab. We have 6 points to go through. Point number 1, all IP addresses are already configured as per the graph. I'm going to use the same network diagram here that I was doing the explanation on, and I will put it also here on top of the page. All IP addresses are already configured as per the graph, so that's fine. Okay. Point number 2, enable OSPF on both router 1 and router 2 by advertising their connected network. Okay, so let's go to router 1. This is router 1 here. I will go to routing OSPF. Here I will put the router ID 1.1.1.1, and we have only the backbone area, which is here. This is the backbone area, and then I will advertise the networks connected to it, which is 192.168.1.0. that's the one connected to the PCs. And we have also 192.168.12.0/24, that's the one connected to router 2. Okay, that's router 1. Then we go to router 2, and then routing OSPF. In here we have to put the router ID for router 2, and then the networks. Actually, I have only one network, which is 192.168.12.0/24. That's the network connected to router 1. And then we have to check if they form neighborship. And here we go. We see that router 2 has formed neighborship with router 1. That's good. And let's see the routes now. So in a moment, router 2 should be able to see also the route of 192.168.1.0, and that's the one where the PCs are connected to. And as you can see now, he is able to see 192.168.1.0/24. Actually, let me just show you that this network over here, I have my real PC connected to router 1 here. So this is still, we are in GNS3, but I'm connecting now my real PC here to the Ethernet 2 of GNS3. And if you want, I can show you that here very fast. So this is how it looks like. So this is my PC. That is my network card GNS3 connected to the switch, and then connected to MikroTik 1 on its Ethernet 2 interface, and here they are connected to Ethernet 1. Okay, that means that now if I go to router 2 and I try to ping to my PC has 192.168.1.254. So it is one of the PCs that you see in them here. So my PC has 192.168.1.254, and you can see that from router 2 I'm able to ping to my real PC because it is in OSPF this network. Then he can reach my PC. Okay. So if you want to do this lab, just be sure that you disable your Windows firewall, and also if you have any antivirus or firewall on your computer, you have to disable them so router 2 is able to send the ping to your PC. So we have enabled on router 1 and router 2 OSPF. Check if router 1 and router 2 form neighborship and learn the route from each other. So that's also, we've checked it, it's fine. Now, they ask us, put Ethernet 2 of router 1 as passive interface. So that's first thing, we need to put Ethernet 2 of router 1 as a passive interface, so the interface which is connected to my PC. And then can router 2 still see the network 192.168.1.0? So why we need to put passive interface? So let me just show you here again. I want to put now Ethernet 2 here as a passive interface to not allow any more hello packet to go from router 1 to the inside network. Okay, so we need first to put it as passive interface, and then the second point, they ask us if router 2 is still able to see this network 192.168.1.0 in his routing table. Okay, he is going to see it because, as I told you, that passive interface will not do anything with the advertisement of the network in OSPF. It will only stop hello packet to be sent from the interface. So let's do that. I will go to router 1, And here we go to, inside the OSPF, we go to interfaces, and Ethernet 2 here is known dynamically, okay? I need to make plus, and then I need to put Ethernet 2, and all I need to do here, I will just make passive, okay? So Ethernet 2 is now a passive interface. And you can see it has now directly a AP. Okay, in this case, this interface is no longer sending now hello packet, but a router 2 is still able to reach the network which is connected to this interface. Okay, so they ask us to check that, so let's do. We go to router 2, and then from here I will go to, again, ping. I will ping my PC 192.168.1.254. That's from router 2. And you can see I'm able still from router 2 to reach my PC, which is 192.168.1.254, which is inside the network connected to Ethernet 2 of router 1. Okay, and also if I will go to routing here and to OSPF, I go to routes, and you can see that indeed we are still able to see the network 192.168.1.0. And if we go to IP routes, and then also we see it here, it's still there. Okay, so this point is done. But before I jump directly to point number 5, let me put it back, the Ethernet 2, I will put it back without checking the passive on it. So I'll go to router 1, and then I will go to routing, OSPF. This one, we checked it passive, so let me first leave it like it was before. So it's not a passive interface, okay? And then what I need to do, I will go to GNS3. There is a very nice tool in GNS3 that you can capture traffic, okay? So if I want here to show you, we put view interfaces. So here Ethernet 1, it is on GNS3, but on GNS3, Ethernet 1 means Ethernet 2 on the router, okay? So this is Ethernet 2 and not Ethernet 1, and this is Ethernet 1 and not Ethernet 0. So always you have to add +1, because on MikroTik there is no Ethernet 0, and on GNS3 they start with Ethernet 0. Okay, so this is still like the graph, okay? You can see on the graph this is Ethernet 2. So what I need to do, I have to start now capturing. I just right click like this and I say start capture. And here you can see directly that Wireshark has opened and he starts capturing now the traffic going and coming inside the interface. We have here one hello packet. You can see hello packet on OSPF on the going to the destination, the multicast 224.0.0.5. So this is one hello packet. Every 10 seconds, as we know already now, that every 10 seconds a hello packet will be sent. That's the second one. Let me first stop it now and let me filter it. I will write OSPF. And you can see in the time that we have opened the capturing, there is 3 OSPF packets have been sent from the interface Ethernet 2. Okay, remember we're capturing on Ethernet 2, so it means that this interface is now sending the hello packets from Ethernet 2. Okay, now what I want to do, I want now to put it as passive interface, and I will want to see if hello packets are still being sent from Ethernet 2. To put it as passive interface, again we have to go to router 1, and from router 1 I will go inside Ethernet 2, and then from here I will go to passive. I will check it and I will say okay, then we know now that Ethernet 2 is a passive interface. Let me go again to GNS3 and I will do again capturing. So start capture. And here we go. Now we are starting the capturing of the traffic of the packet. And you can see before directly we saw the hello packet. Now I'm just trying to look inside here. So as you can see, till now there is no any hello packet shown. We can keep waiting a little bit, and also we will see that we will never get any hello packet. Okay, so I will stop now and I will do display filter OSPF, enter. We can see that we have nothing. So that's really a proof for you that when we put passive interface on an interface which is advertising the network connected to it, it will not send any hello packets anymore out from this interface. Okay, point number 5. Put Ethernet 1 of router 1 as passive interface. What will happen? So if we go back to the graph here, this is now a passive interface, which is fine because it's not connected to any router, this interface. But now they're asking us to put Ethernet 1 as passive interface, this one. And they're asking us what will happen. Just remember, when you put a passive interface, then the interface will not send any more hello packets. And back to the lesson that we talked about, the hello packets, I said that it's very important for the hello packet to work correctly, because the hello packet is the one which helps to form the two routers neighborship together. Okay, and we talked about the criteria inside. So one of the criteria is they should have the same hello interval and the dead interval. We said that the hello interval is 10 seconds and the dead interval is 40 seconds. That means every router, every 10 seconds, he will send a hello to the neighbor to see if it's still connected to it. If we put Ethernet 1 as passive interface, then Ethernet 1 will not send any more hello packets to router 2, then the neighborship will not be formed anymore. And that's going to be a big issue for us. That's why I always say that if you want to apply the passive interface on OSPF, just apply it to where you don't want to have a neighborship in OSPF. Okay? But first, let's now do it and see what will happen. So let me go now directly and put Ethernet 1 as passive interface. Ethernet 1 is still now inside OSPF. It's dynamically known. Then I will have to go here, interfaces Ethernet 1, and I put it passive interface. And then directly we can see here that the neighbor has been gone between router 1 and router 2. There's no more neighborship. Okay, if I go to router 2 now, and we see that the neighborship is still there, but remember the hello packets needs 40 seconds, as we said, the dead interval. So the router will give like 40 seconds for the neighbor router to see if it will come back as neighbor or not. Okay, if the 40 seconds are gone, this interval is finished, then in this case, router 2 will take out, like we see now, the neighborship with the other router. Okay, and now if we go to routes here, we can see that 192.168.1.0, this network is not anymore known by router 2. And if we want to ping, like we were pinging to my PC 192.168.1.254, you can see that there is no route anymore, because we have put Ethernet 1 of router 1 as a passive interface. Okay, let's see now, put Ethernet 1 of router 1 as a passive interface. We have done it. What will happen in this case? The neighborship will be gone, and then in this case router 2 will not know anymore about the route coming from router 1. Point number 6, remove passive interface from Ethernet 1 on R1. Okay, so let's remove it. We go again here, and then to Ethernet 1, and I will remove the passive interface, and then okay, and I look to the neighbors, and in a moment we can see that directly router 1 and router 2 form neighborship. And now if I go to router 2 now, we have neighborship, and also now he knows how to reach the 1.0 network. And if I want to ping again, now he can reach my PC. So this is what I wanted to show you about the passive interface in OSPF. Remember, it's very important to use it when you have an interface which is connected to anything in the network which is not a router participating inside the OSPF. Okay, so in this case, the hello packet will not be sent from this interface, and then this way you can secure that no one can form neighborship with your router who should not really form neighborship with your router. Okay, I hope that this lecture and this lab was informative for you, and I see you in the upcoming